There are quite a few ways that we can solve quadratic equations. And when we look at quadratic equations, oftentimes we try to first see if we can solve the quadratic equation by factoring. If not, then we can also solve quadratic equations by completing the square, or by the quadratic formula, or even sometimes by using what's called the square root property. The completing the square process is something that is also useful in many other areas of mathematics. When we're trying to find a vertex of a parabola, when we're trying to find the center of a circle, or the center of an ellipse, or hyperbola, all of those situations, this process can come in handy. So it's important for us to be able to practice it even in settings such as solving a quadratic equation, even though we have those other methods of the factoring or the quadratic formula available to us. In this segment, we'll take a quadratic equation and solve it by completing the square. Now, the completing the square process actually has several different steps that you'll want to make sure that you keep track of as you're going through. One of the first things you want to make sure of is that the coefficient in front of the leading term is 1. So since we're talking about quadratic equations, the leading term is your term that is the square on it. Next, we want to get all the variable terms on one side of the equal sign and the constant on the opposite side. So we want to sort it so we have variable terms on one side and the number term on the opposite side. Once we do that, we're going to complete the square on the variable terms by taking 1/2 the coefficient of the first degree term, squaring that number, and adding it to both sides. That will force our variable side to have 3 terms, and that the 3 terms will be a trinomial that comes from a square of a binomial. So we're forcing it to be a perfect square trinomial expression. So we'll then be able to factor that left-hand side, and we'll want to combine the numbers on the right-hand side to be able to use the square root property and then finish off and solve for our value of x. So that's an overview of what we're about to do. Next, let's go to an example and run through those steps with this particular example. So it says solve 3x squared minus 18x minus 21 is equal to 0 by completing the square. So to solve it by completing the square, the first thing I want to do is to make sure that the coefficient in front of my x squared term is 1. Since currently the coefficient in front of my x squared term is 3, and I have an equation that has a left side and a right side, I can actually just go through and divide everything through on both sides by 3 so that I get a coefficient of 1 in front of my x squared term. So we're going to divide both sides by 3, which means every term on both sides of the equation will get divided by 3. So that gives me the equation x squared minus 6x minus 7 is equal to 0. Now, for some of you that are quick with the factoring process of solving quadratic equations, you might say, well, I could just factor this equation and solve it that way. And that's true. But again, we're trying to learn how to do the completing the square process in this segment so that it's in place when we need it for other applications in mathematics. So we're going to continue on with the next step. Now it says to get all the variable terms on one side and the constant on the opposite side. So x squared is a variable term, the minus 6x is a variable term, but this minus 7 is a constant. So I'm just going to add 7 to both sides to get it separated to the other side. So I have x squared minus 6x. I'm going to leave space in here equal to, when we add 7 to both sides, I'm going to have a 7 on the right-hand side. Now in step 3, that's the part where we're actually going to make this left-hand side into a perfect square trinomial by completing whatever number needs to go here so that this would factor as identical binomials. We can figure that out by off to the side taking 1/2 of the coefficient that's in front of our term that's to the first power. So 1/2 of negative 6 is negative 3. Square that number, so in parentheses negative 3 quantity squared is going to give me a 9. And I'm going to add this 9 to both sides of my equation because I still need to have it where it has the same solutions as my original equation did. So I'm going to add a 9 to the left side and also add a 9 to the right side of the equation. Now that has made this left-hand side a perfect square trinomial. This factors as two binomials, where I'm going to need an x in both first spots of my binomials, and the factors of 9 that add to be -6 are -3 and -3. Notice they're identical binomials. So I can write this x minus 3 times x minus 3 as x minus 3 quantity squared. And then on the right-hand side, I just want to combine my terms. So 7 plus 9 is 16. Now, if you notice that when we worked with taking 1/2 the middle coefficient in our scratch work over here to get ready to complete the square, when half of the middle coefficient came out -3, and once we added that 9 to both sides and factored it, -3 is what followed the x in the factorization of that side. That will always happen. So whatever half your middle coefficient is what's going to go in this factorization, and it can help out a great deal when you're dealing with fractions. So now that I have it as a quantity squared equal to my value, and I'm trying to solve for x, the next thing I want to do is take the square root of both sides. Don't forget your plus or minus. So the square root of x minus 3 squared is x minus 3, and that's equal to positive the square root of 16. Well, 16 is a perfect square number. The square root of 16 is 4. So x minus 3 is equal to 4, or x minus 3 is equal to -4. Both of those options. And now I will solve both of those equations for the variable. Here I'll add 3 to both sides to get x is equal to 7. Or here when I add 3 to both sides, I have x is equal to -4 plus 3 is -1. So my values of x that make that original quadratic equation true are x equals 7 or x equal -1.